Hello students. In previous lecture we discussed the pin diagram of 8085. We studied all the pins. Today we have to start with addressing input output devices. How we can address the input device or output device which is connected to the processor. And I had told you that input output slash memory bar, this pin is somewhat related to IO mapped IO method or system. So what exactly is there in this topic? And I also had told you that IO slash M bar is related to S0 and S1 pin. That is status pin. See, S0, S1 and IO slash M bar. These three pins are related. How they are related we will see in this topic. What we had learned about S1 was IO or memory control, IO slash M bar control, and same is for S0. These are status pins. So let's see what is there in this topic. Then microprocessor is connected with other devices. Other devices like external memory. It has its own memory, but it's very limited. It is connected to some other devices, for example, some external memory, some external input output devices. If external memory is connected to the microprocessor, some external input output devices are connected to the microprocessor, it becomes microcomputer. Microcomputers can be laptops, desktops, handheld devices like your mobile phones. These comes under microcomputer. Sometimes to select particular input device and output device, particular address is given as a memory location. To an input device or to an output device, some particular memory location is assigned so that I can easily find out, the processor can easily find out where this input device is connected. If I want to send data, the processor will directly send the data to that input device by locating the address. For example, address 0002 is used to select input device like keyboard and 0003 is for output device like printer. Therefore, whenever address is given, microprocessor 002 or 0003, these two addresses are used to select only input or output device. These two addresses 0002 or 0003, they cannot be used for storing any data in that memory location. It will be used only one purpose, to address a particular input device or to address a particular output device. That memory location cannot be used to store any data in that memory location. This system of addressing input output devices, is known as memory mapped IO. Memory mapped IO. But microprocessor 8085 uses IO mapped IO method for addressing input output devices. So what is there in this method? Why it makes it different from this IO mapped IO method is different from memory mapped IO? Let's find out. But in microprocessor 8085, IO mapped IO method is used for input output devices. For example, the address 0002 and 0003, when it appears on address bus, then this address may be memory or for input output devices. In previous method, memory mapped IO, If one address was assigned, one memory location was assigned to some input device, then that can be used only to address that input device. We cannot use that memory location to store any data in that particular memory location. But this is not with IO mapped IO method. If a particular memory location is used to address an input device, that memory location can also be used to store the data. Let's see how. The address 0002 and 0003, when it appears on address bus, then this address may be memory or for input output device, which depends on the control signal present at pin IO/M bar. The control signal which is present at pin IO/M bar, this determines me that this memory is for some input or output device, or is this for to store data. Bar represents active low pin. Okay, so here's the table given. This table, this is the signal at IO/M bar pin. IO/M bar pin, if it is 0 and signal status at S1 is 0 and signal at S0 is 1, it is used to write data in the memory. When again IO/M bar is 0 and S1 is 1 and S0 is 0, it is used to read data from that memory location. When IO/M bar is 1, S1 is 0 and S0 is 1, it is used to write data to the input output device. When IO, so can you see, when IO/M bar is 0, it is used for memory. When IO/M bar is 1, it is used for input output device. The memory location is used for input output device. When IO/M bar is 1, S1 is 1, S0 is 0, then it is used to read data from the input and output device. Okay, then IO/M bar when it is 1 and S1 is 0, S1 is 1, S0 is 1, it is used for opcode fetch. Now what is opcode? I had taken one example here. This was the instruction. This is the instruction of 8085. One of those 74 instructions of 805. So this MVI is known as opcode. MOV is known as opcode. JMP is opcode. Okay, so it is used to fetch the opcode. When IO/M bar is 0, that and S1 is 1, S0 is 1. When IO/M bar is 1, S1 is 1, S0 is 1, interrupt acknowledge. It is used to acknowledge when microprocessor receives an interrupt. When microprocessor tells the peripheral which had sent interrupt request to the processor that yes, I have received the interrupt and I'm working on it. This microprocessor tells the peripheral device. Okay, then here it is floating. Floating means the value is flickering, 0101, whatever. And if it is 00, it is used to halt, stop whatever process is going on, stop. And when it is flickering and these two are unused, it is used to hold. When this is flickering 1010, then these two are unused, it is for reset. I hope you remember what is reset and hold. Hold, I told you, direct memory access concept, and other one was reset. I hope you remember the program counter concept. Okay, now let's read this. For example, the address 0002 and 0003, when it appears on address bus, then this address may be memory or for input output, which depends on the control signal present at pin IO/M bar. When IO/M bar is 1, it is for input output device. When IO/M bar is 0, it is for memory. This address is for IO input output device, and when IO/M bar is 0, then it is for memory. In microprocessor, actually IO/M bar, S1 and S0 control signal decide the type of operation. Just now we have discussed. So S1 and S0 are used in collaboration with IO/M bar. We have discussed this table 1.3. Now the difference between memory mapped IO method and IO mapped IO method. What's the difference? Input output is assigned to the separate address space of memory. Of course, because if one memory location is used for input output device, it cannot be used to store the data. So separate address space of memory is required. In IO mapped IO, that is not the case. Input output is assigned with same address of memory. That memory can be used to store the data also, and it can be used to assign that address to input and output device. Separate control signal is not required. It is required. Separate controller is required in IO mapped IO, which is IO/M bar, which determines whether it is the address bus is for input output device or it is for memory to store the data. Memory space is reduced due to insertion of input output address, because memory space is fixed. Some memory space is used for input output device and some memory space is used to store the data in the memory. So of course it is reduced. Full memory space can be used because one memory location can be used for determining the input output device, and simultaneously it can also be used to store the memory data into the memory. It requires 16-bit address bus and it uses 8-bit address bus only, because it requires 16-bit address bus to locate one particular input output device. It uses 8-bit address bus only. Like one 8-bit can be used with data bus. Here separate address bus of 16-bit is required. Okay, so this was the difference between memory mapped IO and IO mapped IO. In 8085, which method is used? IO mapped IO, which is efficient method when compared to memory mapped IO. After this, we have topic internal block diagram of 8085. We have learnt block diagram of generic microprocessor. So a general microprocessor, what all things it can have, that we have already discussed. So internal block diagram of 8085 will be easy for us to learn, because the blocks which I have learned in generic microprocessors are almost same in internal block diagram of 8085. Those topics which we are going to learn will be almost same. So we will stop here for today. We will start with internal block diagram of 8085 in next lecture. Thank you.